In this series of lectures, we'll work on functions and graphs. We'll start with graphing functions. Graphing functions is one of the most important pre-calculus tools that you'll use as you move forward in higher level mathematics. In particular, it will be important that you're able to sketch graphs of functions using a variety of tools. We're going to start with a quadratic function, as this is one of the most common functions that you'll encounter as you move forward in calculus. Here we're asked to sketch a graph of the function f of x equals 3x squared minus 12x plus 17. We're going to do this by completing the square to find the vertex of our parabola. We've seen how to complete the square previously, so we want to express 3x squared minus 12x plus 17 in the form a x plus h squared plus k. So we need to find our a, h, and k. We do this, as we've seen before, by expanding. We get ax squared plus 2ahx plus ah squared plus k. We can now identify coefficients, so the coefficient of x squared, which is 3 on the left, must be equal to the coefficient of x squared, which is a on the right. Similarly, we get that 2ah is equal to negative 12, and we get that ah squared plus k is equal to 17. Since we know a, we can plug 3 into our expression 2ah equals negative 12 for a, and so we get 6h equals negative 12, or h equals negative 2, and similarly we can plug in a and h to solve for k, and we get that k is equal to 5. So what we've now seen is that we can express this quadratic function in the form f of x equals 3, x minus 2 quantity squared plus 5. And as a check, you can pause this video and go ahead and expand this thing out, and you'll see that we do get 3x squared minus 12x plus 17. Okay, so let's talk about how this helps us sketch our graph. So first of all, I notice that when x is equal to 2, my x minus 2 squared term will be 0. Anything squared is definitely positive, so this entire term is always greater than or equal to 0, which means the minimum value of my function, or the minimum point in my parabola, is going to be when x is equal to 2, because x equals 2 makes this term 0, and I know that this entire expression is a positive number 3 times something squared, which is always positive. So I know that when x is equal to 2, 2 minus 2 is 0, so we get f of 2 is equal to 5. So when x is 2, y is 5, and I've plotted this point here in our parabola. So we have one point in our parabola, and we also know that this is the minimum value, or the smallest point in our parabola. Again, this is important to understand why this is the case. We know that 3x minus 2 squared is always a positive quantity, so the very smallest it could be is 0, and that occurs when x equals 2. Now, what's another easy point to plug in? Well, I know that when x is 0, y is equal to 17. That's the y-intercept of my parabola. I could plug it into either form. If I plug into the first, it's very easy to see quickly that when x is 0, y is 17. Over here, I would get, plug in x is 0, we get minus 2. Minus 2 squared is 4, times 3 is 12, plus 5 gives us 17. So I have the point 0, 17. Now for symmetry, I'm going to see what happens on the other side of x equals 2. So I have a distance of 2 from the x equals 0 that I plugged in and the x equals 2 that we plugged in. I'm going to go out to on the other direction and see what I get. So again, we know that when x is, so going out 2 in the other direction would put me at x equals 4. When x equals 4, I again get 17. This allows me now to sketch the general shape of my parabola. So here now is the graph of our parabola 3x squared minus 12x plus 17, with these important representative points that we've labeled to help us get the shape of our parabola.